All right. I don't know if we are recording or not. Hey, we are recording. Okay, sorry for the delay, guys. Been having a little trouble with this program, but hey, this is your instructor, Karen Klein. It's good to be with you once again. Today's topic, or this week's topic, is the atmosphere and air pollution. So as far as this chapter is concerned, or this lesson this week is concerned, you are going to be focusing primarily on pollutants and the consequences of those different pollution types, as well as the solutions to the challenges that we once faced and continue to face. But just a little bit of background here. We are not unique in the solar system in that our planet has an atmosphere. Almost every planet have atmosphere. Every planet has an atmosphere, that is an envelope of gas that surrounds it. Even some moons of some of the planets have atmospheres. Now, of course, our moon does not. But our atmosphere is unique in the way that it contains it is comprised of the gases and other materials that it does that allows there to be very complex life forms that exist here. So, what are those particular gases and why are they so important? Some are more important than others in our discussion. Now, some, of course, are more important in regards to living things, but they all allow there to be life on our planet in one way or another. So we have gases. That is mostly nitrogen, actually, more than oxygen, but those two together make up most of the gases in our atmosphere. There is some carbon dioxide, a teeny little bit amount, and carbon dioxide is extremely important in that it is a greenhouse gas. It holds heat in, and so therefore when the sun shines and brings us all of that wonderful thermal radiation, it actually is able to keep it from escaping out into open space. Now there are other greenhouse gases as well, like methane and water vapor, but that is the primary role of carbon dioxide. There is water vapor in the air. That's water in the form of a gas, and it's water vapor that as a gas that condense onto, that is water then in the form of a liquid, condenses onto some of the solids in our atmosphere. These particulate matters or aerosols. And they can be teeny little bits of dust. It could be bits of smoke. I mean, we're talking really, really, really tiny smoke from volcanic activity or from human activity, salt particles from wave action. And it's this water vapor, this water as a gas that condenses onto it, turns into a liquid, and forms tiny little water droplets that form clouds. I mean, think of it if you have like a glass of cold water on a warm day and you leave it out. The air, or I should say the water in the form of a gas, condenses onto the outside of your glass. It turns into a liquid. The same mechanism, the same properties that occur in the formation of water droplets that then form clouds, which allows for the water cycle here on our planet, which is extremely important, of course, when it comes to life on our planet. So we have gases, liquids, and solids that comprise our atmosphere. Now, a little bit of background to make the connection between the components of air and how this affects us is that now not all living organisms need oxygen, but we'll talk in our discussion, we'll talk about the ones that do, us, namely, and that is that we bring in oxygen in through our lungs. Now, not all animals do that this way. I mean, some animals actually absorb it through their skin. Fish will actually bring oxygenated water across their gills, which extract oxygen. But nonetheless, we use that oxygen to build energy molecules. They're called ATP molecules. And then what happens is we exhale out, humans exhale out the waste gases, water vapor, carbon dioxide, and nitrogen. In the waste gases as a result of our making ATP and other metabolic processes. There's a short video that I encourage you to watch if you are interested in seeing that in a film type of format. So this is awesome. You know, oxygen gets carried in through our lungs and way down into the teeny tiny branches of our lungs called the alveoli, which have, as you see on the bottom here, that forms an interface with our bloodstream where oxygen crosses that membrane through diffusion into the bloodstream and gets picked up by red blood cells and then carries that oxygen throughout our body. And also in the alveoli, carbon dioxide, those waste gases, diffuse across to the alveoli and then get released as we exhale. Now, the reason I point this out is because, you know, in the same way that oxygen gets carried throughout our bloodstream, there are other components of air, some molecules like nitrogen that's naturally in air, that they're just too big. They don't cross that membrane into our bloodstream, and they just wind up getting exhaled. But there are other components of air, you know, whether it's in the forms of solids or the forms of gases that are pollutants that can either get absorbed into our bloodstream along with oxygen, or like particulate matters like dust and soot will clog up these alveoli and won't allow us to breathe, won't allow us to bring oxygen across this membrane into our bloodstream. Now, sometimes people it's harder for some people to make that connection between air pollution. You know, they can say, oh, sure, you know, air pollution causes problems with your, you know, your trachea, your windpipe gets irritated, or your lungs hurt, like respiratory diseases. That's a pretty direct connection with air pollution. But, you know, when we say air pollution also causes afflictions like kidney failure or cancers or headaches and dizziness. Sometimes people aren't sure, like, well, how could something you're breathing in cause cancer to an organ? And it's because these toxins get carried through your bloodstream, through all of the different tissues in your body, just like oxygen does, and then therefore work their way into your tissues and cause the cells that make up your tissues, you know, the cells make up the tissues make up the organs, to go faulty, to be affected. And that video does explain that quite succinctly. So what is pollution then? I mean, you saw the components of natural air, and a pollutant is just basically any component that, well, doesn't belong there, but that is harmful to living organisms. And, you know, we're talking about people, but it can also be pollutant, of course, to all living things. Now, where do they come from? Well, the number one cause of, or source of pollution, is in fuel combustion, specifically in transportation. You know, fuel combustion also occurs in manufacturing and industrial processes and natural sources, but most of your pollution comes from transportation, the fuel combustion that is the result of transportation. And you can have these pollutants that are directly released into the air through these processes. We say those are primary pollutants. But what can be really problematic, unfortunately, is what then happens is you have these chemicals that are released into the air, and they mix with each other, and they also react to sunlight. And that then changes the chemical composition. The atoms that make up the molecules kind of do little dances. They switch partners, and they form these other harmful molecules, which we refer to as secondary air pollutants, that are formed higher up into the atmosphere. And they're both equally harmful, primary and secondary air pollutants, to the health of living organisms. And it is absolutely a big problem, obviously. I mean, when you think of, your food being contaminated, or even your water being contaminated, at least I'm talking more so like in the area where we live here, where we have lots of different sources of water and different sources of food, we can try to avoid it. You can have a water boil advisory. You can have a don't eat that food or this food. But the air is all around us, and we don't have too much of a choice as far as the air that we breathe. Short of sometimes you see an advisory where you have to, if there's some sort of a chemical spill, you're advised to stay inside and keep your windows closed. But, air still gets in, just maybe not to the same degree. Or, it's hard to, not everybody can whip out an oxygen tank and start breathing oxygenated air, or gas masks handy so you can walk around. So it is quite challenging in regards to avoiding air pollution, and oftentimes we don't even know we're being exposed to this, but there is a lot of that. Now, there are some areas that have more problems with air pollution than others. They tend to be these urban areas, and depending upon geography, that can also be a problem. You can have an urban area that might sit low, for instance, and they tend to have more problems because of what we refer to as smog, NOx, nitrogen oxides, VOx, volatile organic compounds, mixed with the sun and particulates, which then would form ozone at ground level. Los Angeles has a problem with this, and Mexico City really has a problem with smog. You see the photo up there at Beijing, big problem with smog, just because of the mixture of geography, as well as the sources of pollutants are so concentrated in cities. But you also have problems with, if you have pollution that is high up into the atmosphere, it gets carried by winds to a completely separate location. So you may have pollution that occurs not at the source, but hundreds or even thousands of miles away. And as you see through that graphic, you have not only have a lot of pollution in the atmosphere, but the bottom graphic, I should say, shows all of the different ways that air pollution can manifest itself. So it definitely is something that we as humans are vested in finding solutions to these particular challenges. The major types of pollution, the particulate matter is one that, and I go through in more detail in these, so I'm not going to harp on this particular graphic. It's a good graph, but particulate matters, sulfur oxides, nitrogen oxides, carbon monoxides, and ozone are certainly these big categories of air pollutants, but there are others which we will also touch upon. Your volatile organic compounds, what we call your VOCs. Now, these are ones that, we think of air pollution, we think of cars and industrial processes and big manufacturing plants, and but these are problematic because these are found mostly indoors, inside your homes, inside your cars, inside, not just your homes, but just any building, really, because, they are those which, the diffusion of the chemicals that are part of the manufacturing of these particular products, and then the chemicals just diffuse into the air, and you think like how could that be? Like you think of pollutants being again like being released by some process actively, like during the manufacture of them, but they continue to release these chemical compounds even after they're made. And just think, if you can, now not all pollutants you can smell, but if you can, that new car smell, or you go into a hotel, or you have, you can smell that, or you have carpeting put down, or you have, you're using glues and it's a strong scent. Those are gases that you're smelling. They're molecules that you're smelling and bringing into your body. And you see all of the different, problems that can result of these volatile organic compounds, respiratory, immune effects, eyes, nose, throat irritations, headaches, nausea, liver damage, kidney damage, central nervous system damage, and cancer. But through just the building materials in your house, carpets, adhesives, ceiling caulk, paint, wood products, varnishes, vinyl flooring, air fresheners. That's a big one. All the Febreze that people are smelling or spraying around. Just the smell of gasoline, even you don't even have to burn it. That there are toxins released just with gasoline. Different types of cosmetics, mothballs. I don't know if people still use them. I know my mom does, but I think she's 78 years old. Cooking, cleaning, space heaters, dry cleaning, all of these are releasing these pollutants that have been shown to be harmful to human health. And as we discussed in the ecosystems lecture when we were talking about toxins and ecosystems, this doesn't take into account these synergistic effects. There's a little overlap, of course, with that lecture. That is, if we know what's in paint, for instance, how does that work once you paint a room if then you whip out your air freshener and freshen up the room that way, and then you have a space heater, and then you bring in your dry cleaning. There's just all sorts of different chemicals that we're just stewing in from an air pollution standpoint. So air pollution, so it goes, isn't just the air outside, but most air pollutants are actually found indoors. Particulate matters are those tiny, tiny little particles that are suspended in the air, and they themselves can actually carry molecules on them, like toxins on them, but they can also act to clog up. We're talking about really tiny pores, I can't think of the right word, in your alveoli that gases need to travel through. And if you are breathing enough of these particles, these particulates, that can cause a clogging effect or just disorders. Our respiratory tracts are actually lined with little hairs, as well as little microvilli and little extensions from the tissue that are meant to capture these before they get to our lungs. And that's why we have our respiratory tract is lined with mucus, because the mucus is sticky, as like snot, whatever, and that traps particulate matters, as well as like it's meant to trap bacteria and other and viruses. And then our bodies naturally kind of bring it up to the back of our throats, so we can then swallow that, so we don't get this trapped. So it keeps all this crap from getting into our lungs. down deep into our lungs, and some of these particulate matters, when taken in high amounts, will actually paralyze those little hairs and won't allow us to be able to do that. So it certainly is is very problematic, these particulate matters, in addition to the different gases in the air. And then, we touch on this CFCs, chlorofluorocarbons. These are, or this is a molecule or a chemical that actually breaks down ozone. Now, we mentioned ozone. Ozone, when it's at street level, human level, is considered a pollutant. But ozone is found naturally in our stratosphere, high up in the atmosphere. And what ozone does, and ozone is 3 oxygens that are attached together. Usually oxygen is just atmospheric oxygen has 2 oxygen atoms bonded together. Ozone is 3, but this ozone layer in our stratosphere is super duper important, because what it does is it filters out a lot of the nasty UV radiation, mutagenic radiation, that the sun is chucking at us well, not when the sun goes down, but when the sun is up. I mean, the sun gives us all kinds of electromagnetic and otherwise radiation, and this ozone actually filters out the really bad stuff, the stuff that mutates DNA. And if it weren't for this ozone layer, we wouldn't have life on our planet. In fact, when they talk about terraforming Mars, that is one of the concerns, is that the sun's rays are extremely mutagenic, because there is no ozone layer to filter those out. And so that's one of the challenges in order to allow to eventually make Mars habitable, is to find a way to filter out these mutagenic rays, which is why they talk about, if we ever go to Mars, we would live underneath the surface to prevent that. But anywho, I digress. Sorry about that. Now, chlorofluorocarbons is a pollutant that is found in the manufacturing of styrofoams and refrigerants that was shown to actually break up this ozone in the stratosphere. And we were finding that our ozone layer was thinning, and also there were holes in the ozone layers. You see in the graphic that is over Antarctica. And this is really a huge issue, obviously, because if there's no way to filter out those really bad UV rays, then we can't exist here, which obviously is something that we're all vested in doing. And we've seen, increases in cataracts and skin cancers, and even just premature aging, which is somewhat aesthetic, but is symptomatic of a bigger problem, in that problem of our ozone layer thinning, or the overall destruction of the ozone layer. We have lots of challenges, whether you're inside, whether you're outside. Primary pollutants, secondary pollutants, volatile organic compounds, sulfur oxides, which we call SOx, nitrogen oxide, which we call NOx, too much particulate matter, too much CFCs. So what are the solutions? And I'm so happy to report that this is a success story in the U.S., I should say, in our history, as far as combating this problem. So what are some of the solutions? Well, there isn't just one solution to almost all of these environmental challenges that we face, but one category of solutions is laws and legislation. That is, way back we talked about the environmental history of laws and legislation, and back in the early 1970s, when we formed a lot of these laws. Sorry, my parrot is starting to get upset. You can hear her in the background. But this is when we had these laws and legislations that were put into place in order to, ensure that we have clean air. Of course, it's kind of a slam dunk, isn't it? But there are some of these laws that manage the source, like as far as manufacturing and making the effluents cleaner. There are conditions put into place where they are monitored and air is tested and laws are enforced as far as the keeping these effluents from getting out into the atmosphere and preventing the manufacture of other types of pollutants or processes that form these pollutants. And specifically to what's cited here, specifically to the CFCs as far as the ozone layer, is that many of the countries of the world just said, hey, we need to work together here, put our differences aside and say, we need an ozone layer. This isn't just a United States problem or a Canada problem or, what have you, name any country. And so for the most part, we cut significantly the CFCs that were used and what we call the Montreal Protocol. And it is one of those particular treaties in which, we point to say, hey, look, as a world and humans as a species can all work together for the good of everybody. And I'm talking about global climate change, of course, but and the Montreal Protocol has actually been extremely successful. And our ozone layer has, since this was put into place, has actually started to regenerate itself. So these laws and legislations have been a key part in preventing air pollution from, lots of words, have been key as far as preventing air pollution. Now, with laws and legislation, there has to be the technology. We can't say, and we should have no manufacturing, we should have no fuel combustion, no more cars, no more airplanes. That is impossible. One might point to that and say, well, that's idealistic. We should return to a completely agrarian society. And well, that is basically impossible. So we have invented some technologies to help remove the pollutants that are formed during these processes of fuel combustion, manufacturing, and industry to prevent that effluent from getting into the atmosphere. Now, on a large scale, but can be on a somewhat smaller scale, we have bag houses and scrubbers. These physically remove mostly particulates, especially the bag houses, but other gaseous pollutants as well. And it's the physical process, like a bag house, for instance, is kind of bad example. Vacuum cleaners don't really use filters anymore, but there are air filters in your house. If you have an HVAC system, there's air filters in your car that capture in like a fine mesh particulates, so they're not released into the atmosphere. As you see on the on the left-hand side, that these bag houses actually filter out these particulates before they go into the atmosphere from a manufacturing process. Scrubbers, same process as a physical process, but they use actually fine mists of air to capture those particulates and other pollutants. And then those fall down into like a pool of water. And then that water either goes to like a hazardous waste disposal, or the pollutants can be, you can remove the pollutants, and then the sludge, we talk about wastewater treatment, that'll become more apparent, like the solids that is taken to a hazardous waste site. Now on smaller scales, but a little bit more advanced technology from using the chemistry and the electrical properties of ions here is that, and on a smaller scale, we have electrostatic precipitators, which actually can be a bigger scale, I correct myself. Catalytic converters, generally these are found in cars. And electrostatic precipitators, they have plates of a certain electrical charge, and opposite charges attract. And so these pollutants, at least some of them, the particulates, have a sort of a charge. And you know what? I'm going to end there because my phone's ringing and I have to get that. Hold on.